Hello. This is the first lecture in a series of lectures about modeling in Solidworks using the sheet metal functions and parameters. First thing you're going to want to do is open Solidworks, obviously. This is how the window comes up. If you highlight over this arrow, you'll get some of the pull-down menus, and you can click on this little pin to lock it in place. This is where you can either go File, Open, or rather File New, or you can pull down here, File New. Start a new file. You have three different possibilities in SolidWorks. You start a part, an assembly, or a drawing. Drawing is self-explanatory. The assembly is, as you can see, a 3D arrangement of parts and other assemblies. And a part is one instance or one piece that you can later instantiate into an assembly. We're going to just start with a simple part. SolidWorks is a parasolid-based modeler, and it is feature-based. These are the features. They're grayed out at the moment because there's nothing to build upon, but the features act as a three-dimensional means to add an attribute to a sketch. An attribute can be anything from an extrusion, a hole, a fillet, a mirror, a shell. These are all three-dimensional. A sketch, which is what we're going to start with, are two-dimensional. Sketches are exactly what you think they are. They're curves and lines, arcs that you're drawing that you're later going to use as a reference point for your three-dimensional sketch. First thing, this is your coordinate system. Excuse me. Unlike other modelers, Z, as you can see here, is pointing out of the screen at you. Y is actually pointing up. X is pointing to the right. Typically, when you're modeling, you're seeing something more like this in Rhino, where Z is up and Y is out, and Y is going away from you, and X is to your right. But this is not the way SolidWorks models. So just be aware of that, and we can talk about coordinating between Rhino models and this coordinate system. So first thing you want to do is you want to turn on a couple things. Right now you can't see an origin point. If you go to View, Origins, there's your origin point. You're going to also want to go to View and turn off some of these things: parting lines, routing, annotations. You really only need a few things. Coordinate systems you can leave on, axes, planes you can leave on, sketch relations you can leave on. But you want to turn origin on. We're going to build everything around this origin point. So the other thing you need is this. This is your sheet metal toolbar. If it's not there, which it won't be, you right click into an empty space, find your sheet metal toolbar, there it is, just place it somewhere up on your screen. Now there's a couple different ways that you model in SolidWorks. The first way is by either starting a new sketch, and it'll ask you to select a plane. By the way, I'm holding the middle mouse button, the wheel, in order to rotate around. If I hold Control and the middle mouse button, I can pan. So if I just start with a sketch, it'll ask me for a few things: front plane, top plane, right plane. These are the standard planes that SolidWorks begins with, and it's asking you to begin by starting on a sketch on one of these planes. Let's exit this sketch. You can exit by clicking this to exit, or you can hit the X mark here. You can see here on your design tree, this is the design tree on the left side, the different planes: front, top, right. And there's your origin point. So you can always click on one of these to reference them or to build on them. The other way we could start modeling is by actually going right to a 2D element or a 3D element. The sketch was a 2D element. Features here are all 3D elements, and the sheet metal toolbar that we created is also the same as the features here. They're starting with 3D elements. If I click on Base Flange tab, you can read what it says: creates a sheet metal part or adds material to an existing sheet metal part. So this is the tab you have to start with to create a sheet metal part. I can click on that. It's going to ask me a plane to start sketching on. It defaulted to the right plane. If I come up here, hold on, this is View Orientation, and this one is display style. So if I pull down view orientation, I can switch to the top view, I can switch to various isometric views. So let's start with isometric. Basically, let me get out of this sketch. So same thing, if I start with the sheet metal part, it's going to ask me a plane on which to sketch a sheet metal feature. So you see what happened here. Let me get out of this. I can either start with the sketch, it's going to ask me a plane to start on, or I can start with the sheet metal feature itself, and it's going to ask me a plane to start on. What I want to do is actually start with the sketch itself, and I'll show you why in a moment. So if I begin with this sketch, I have to click on this window in order to open a sketch. I'm going to select the top plane. We're always going to be sketching on we're going to be starting our sketches on the top plane. And first thing I want to do now is I want to pick a geometry to begin to sketch. And let's just sketch this rectangle. This is going to become our 12 by 24 inch rectangle. So I can just keep drawing more rectangles, more rectangles. I don't actually need all these, I just need one. I'm going to undo these. If I'm in this mode where I'm drawing, where you see the pencil here, right? You can just hit escape to get out of that in order to get your cursor back. You can select this and delete it. So, a couple things. Right now I've got a rectangle. I'm going to actually rotate this so we're looking at it more in isometric. Right now I have a rectangle. There's two ways that Solidworks operates. It operates through geometric references. So if I look at this, that's a vertical reference. This line has been assigned a geometric relation that is vertical. This one's assigning a geometric relation that's horizontal. If I was to select this line and this line together, let me get out of this. If I was to select this line and that line together, I now have a series of other relations I can add to this. I can tell them they're perpendicular. I can tell them that if I try to tell them that they're parallel, I'm going to get an error. You see, it's over-defined. When you get an error like this, the yellow ones are telling that there could be a problem, and the red ones are saying that there is a problem, and it's unsolvable. The reason for this is that you're trying to tell it two things. You're telling it that they're perpendicular and parallel simultaneously. If I click on that parallel relation and delete it, we're okay. We're fine again. I can delete this relationship as well. If I went ahead and just deleted all these relationships, now it's completely undefined. Blue means that it's undefined, or that you can add more information to it. What I can do is, turn this into any sort of shape I would like, but there's no way to control this at the moment, right? It's just a shape. There's no dimensions. There's nothing on it. If I was to begin to add relations back to it, I can select that line, hold Shift, select the line next to it, come here and tell it, okay, I want that to be perpendicular now. Well, so that's changed one aspect of it. If I select this line, if I select this line and this line, I can say that I want those to be parallel. So that actually doesn't work very well. Let's undo that. Let's select this line and this line, tell those to be perpendicular. Well, let me see what happens here. I can pull on these, so those are now perpendicular. If I look at this at the top, but we're getting sort of a, basically we're getting kind of a parallelogram of sorts, right? We're kind of building that up, which is not really what we want. But as soon as I lock that into being perpendicular, now we're beginning to get a square. This is not ideal because, as you can tell, there's a certain rotation to it. So let's tell this line to be horizontal, and now we've locked that in. You see what I've done? So we've got a square. These are all perpendicular to one another, all these lines, but it's rotated in space. In order to get that rotation out and make it parallel to the to the origin, if we were to draw a line clean through the origin, I can just give that a horizontal relationship. Now, if I begin to drag any of these vertice points, it stays as a rectangle or a square, depending. So what I would like to do actually is I'm just going to reassign the original relationships to this rectangle that we had, which is horizontal, vertical, and vertical. It's essentially doing the same thing that it was doing before, but I just want to keep it simpler. So now we've got geometric relationships to one another, all these lines, but there's no dimensions. If I click on this line, you'll see a dimension, right? This is the dimension of that line. I can change this. It can be 4 inches. This line can be, 12 inches. But the problem here is that you don't want to go into each line to edit that. Although you can if you'd like to. But what we're going to do here is we're going to add a smart dimension. So that dimension, we'll pull a dimension string, 12 inches. That's what we had just entered. We want this to be 20. We want this to be 12. Well, 12 inches is actually fine, because we're going to build up vertically. So the other line, 4 inches that we'd entered before, make this 24, right? So there is our sheet metal part, the very basic part, right? This the 12 inch by 24 inches that we ordered, the material that we've ordered. So what I want to set up now is a series of construction lines, because I want this origin point in the center of this rectangle. In order to do that, I click on line, and you have a couple options here for construction. So I'm going to click for construction. Now if I hold over this line, a geometric relationship pops up. Right now this is a coincident relationship. If I hold it over the midpoint, I'll get a relationship between the vertice point of this line I'm about to draw and the midpoint. Now you can see what's happening if I snap to this ortho snap. I get a vertical line here, right? It's automatically assigning a relationship. I can go off of that and snap to any of these lines. That's a coincident relationship. If I click there, now if I hit escape, I can get out of that drawing mode. There's a couple things happening. Now this is moving across, but I can move this vertice point of that construction line anywhere along this line, but if I can't move it off of that line. If I want to move it off of that line, I have to delete the coincident relationship. Now I can pull it again. Do you see what is happening? This tip here is completely undefined. This vertice point is defined as being the midpoint, as being coincident with the midpoint. If I was to select this line, shift, select that vertice point, now I have a couple options, midpoint and coincident. I want it to be on the midpoint. Perfect. So now that is locked into this piece. This piece, I'm able to pull this around in space because there's nothing locking it in space at the moment. We've locked it in relation to itself, but we haven't locked it into space yet. So the next thing we're going to do is we're going to create another construction line for construction. We're going to go from this midpoint, and let me just show you something. If I wanted to take a line for construction and I just drew it in space like this, right? There's no hit escape to get out of here. This line has no relationship to anything at the moment. But I can select that vertice point, select this point, click midpoint, select that vertice point, select this line, click midpoint, and now we've got an axis. We've got a construction axis that we're able to use in order to position this in space. So you're always able to delete relationships or resize this, right? We can make this 12 inches. That'll turn into a square. At any given point you can change all these parameters. That's the definition of a parametric modeler, that all these parameters are built into the design tree and build off of one another. Now you can see what happened here. If I change this to 12, it pulled up from the bottom. We want it actually to scale from both ends if we change this number, which is why we're going to establish this origin point. Select that. We're going to select this line. We're going to select this line, and we're going to click intersection, right? We selected two lines and a point. That now is an intersection on that origin point. It's turned, this whole rectangle's turned completely black, right? We can't actually move anything anymore. We can't pull a vertice point, we can't pull a line to move it in space. It's completely defined. It could become over-defined if we added more relationships, right? If we selected these two lines, told it to be parallel, there'd be an issue. Control Z, undo. But now if I change this number, if I change the dimension on that side to 12, it pulls in from both sides. Right? Change this to 6, pulls in from both sides, etc., etc. So this is actually a very powerful way to set an origin and be able to build off that origin as a reference. So you can either click this to exit the sketch, or you can click this arrow to exit the sketch. If you hit the X mark, it'll erase everything you've done. So when you get out of this, I'm going to save this right now. File, save as, and I'm going to call it this is Solidworks Lecture 01 Edge Flange. We're going to be modeling the edge flange. This is a part file. You can save it as a whole lot of other options, right? You can export the IGES. This is what we would use to export it back to Rhino. There's various other capabilities. We're going to save it as a part file. So now we've got our part. The reason we created these as construction lines is because we don't want them, you can only have one closed curve if you try to do any extrusions. And the next thing we're going to do is we're going to go to our base flange. We're going to select that. Now remember, before when we selected that, it only came up with the three axes, or the three planes, front, right, and top. Now we have the option to select a plane, and if we pull down this menu, this is the same thing as this design tree, right? But the reason that it's moved into this onto the graphic window is that now we can use this to highlight planes, or if you had a whole series of sketches here, you can then navigate through in order to select things easier than if trying to select them graphically in the window. So there's a graphic selection capability, or there's a capability of selecting something in the design tree. So we don't want to select a plane now, because we've already have our sketch. So we're going to select an existing sketch to use for the feature. Select this sketch. You see what it's done? Let me open up a second window here. So in the view orientation, you can also select multiple windows. I'm going to turn this one back to ISO so we can look at that. This is now in the, let's see, if I click in this window, you can see these options move from one window to the other. So we're in the right view. Good. So you can see what's happened here. This has a material thickness now, right here. If I adjust this thickness, you can see that growing. Right? So this, you can be very specific with this thickness. And we're going to actually call it out. This is where when you measure your material, this is where you enter that exact thickness. We're going to call that out as 32nd of an inch. Check. And then just pause this. So we've got our material thickness. Now if I look at this menu here, then we can expand. That sketch that we made is now part of this base flange. If you notice that we have a sheet metal feature here, we have the base flange. If I click on this, left or right click, I can have an option to edit this sketch. Alright, so now I can come in, I can make this 6 inches, we'll edit the sketch, we can get out of this sketch, and it adjusts the base flange. If I click on the base flange, it says edit feature. Now what I can do is begin to add more material thickness to this. Right? So now this has become thicker. So every time you have a 2D sketch and then assign a feature to it, a three-dimensional feature, this sketch will become instantiated as part of that feature. It'll go into like a sub-tree menu. So let's go back to this feature, edit that, put this back to 0.325, and let me just check something for one moment. Okay, yeah, I was just checking. Actually, we're going to make this 0.30125. Sorry, that is 1/32, which is what the material is. Okay, so we've got our base material, we've got a coordinate system, we've got our origin in the center, and if I look at the sketch, if I just click on the sketch, you can begin to see the dimensions that are in here, right? So we've got 6 and 24. The first sheet metal function we're going to start looking at is the edge flange, and that's up here. So edge flange, as you can read, says adds a wall to an edge of a sheet metal part. So because it's adding material, we actually don't want to. We want to reduce the sheet down from the original 12-inch width to something smaller. Let's start at 6 inches, because you're actually going to be adding material to this sheet, as you'll see in a moment. So I'm going to click edge flange. Now you're getting a series of parameters here. If I hold the cursor over this window, it says edge. So the first thing you want to do is define an edge, and it can be the top or the bottom of this edge, it doesn't matter. So, and you can see what's happening. Let me zoom out a little. It's asking you to pull an edge up. You can pull the edge down. I'm going to come into this window here and turn this view to the front view, and you can see what's going on. Oops, front view. So you can see how this is moving up and down. You can select graphically and move it up and down. It doesn't matter its orientation at this moment. So if you click the check, if you just click into space, it'll lock its position. So at the moment we have it going down. Let's say you wanted it to fold up. You can come in here, flange length, reverse direction. Right, so all these options, if you hold over them, all these buttons, if you hold over these buttons, it'll define what it's doing. So this is the flange angle. So let's actually fold this up first. Let's leave the angle at 90 degrees. So if I click in this window, it'll update. And let's turn that, let's make that a 2-inch flange going up. Right, so we've got 2-inch flange going up. Now if I begin to adjust this, you can see how the angle's adjusting. One requirement or one constraint is that you cannot have any interior angles less than 90 degrees. So this angle right now at 118 is not allowable. You could do 70 degrees and have it bend out the other direction. That's completely fine. You just can't have any interior angles less than 90. So let's leave this at 70. Let me zoom right into this little corner here, because I'd like to show you something. Actually, we'll zoom out for 1 sec. And I want to show you this piece down here. This is measuring the interior angle. So saying from this point, from the fold line to the top of that flange is 2 inches. If I was to select this, this measures the outer angle. And you can see, if you look at this gray tip here, when I switch back and forth, that edge grows or shrinks. It shrinks if I select the measuring, if I say that we're measuring from the outer angle. We want to always measure from the inside. So just that's the default, leave it on the inside. The next thing I want to show you is how it offsets the material. So part of the functionality of Solidworks is that it's actually calculating how much. There's a standard bending radius, which we're not going to play with. You know, here it is. Use default radius over here on the left side. We're not going to play with that. The default radius, it calculates that through the material thickness. So, but what we can play with is where this bend occurs in relationship to the material. Right now, if I flange position down here at the bottom left, material's on the outside, meaning that this is the edge of the original material, and all the bend is occurring on the outside of that, right? This flange is coming from the outside. If I say all the material's on the inside, you can see what happened. It moved this flange in so that the outside of this is beginning, the outside of this material is on the outside edge of that original base flange. So that's material on the inside, this is material on the outside, and then this one here is the bend, the complete bend is on the outside. So the whole thing is offset. So this is actually not what we want, first of all, because it's adding material to get that bend. If we click on the, have it bend on the inside, or rather if we have it bend on the outside, it's also adding a little bit of material, right? Because the bend itself requires it to be, the interior edge to be on the outside of this flange. So we're going to have it bend completely on the inside. So that way we're never exceeding this 6-inch dimension here is that we assign for this base material is still true. So you're going to have the measuring the interior angle, and you're going to have the flange position always on the always on the inside. This is going to be true for all the flanges you make. That's just going to be a constraint. So check. So now you can see we've got this. We've got one flange. Here's the flange edge. If I open this up, you can see there's a sketch, and then there's the actual edge bend itself. At any point, you can come in to modify any of those pieces. Never modify the edge bend. It's just not. SolidWorks has created it, and there's a mathematical understanding within it for why it has to be this way. So we're going to leave it. You can, of course, come and edit the sketch if you want. All right. So if I go in to edit the sketch, you can see here it has a similar relationship to the rectangle that we made previously with the horizontal and vertical geometric relations. And then there's this line here. And this is something we're going to see later. This square is saying, if you hold it over on edge, is that this square is referencing that edge of the material, which is what allows us to adjust that edge, adjust this material, and have it stay consistent. So what I'm saying is, if I go into this base flange sketch, edit that sketch, turn this dimension from 6 inches to 4 inches, whole piece shrinks, the flange that we just created is going to move with it. Right? Pretty basic operation. Let's find it in here. Zoom fit is right here. So pretty basic operation, but very important, especially for later on when we're creating more relationships from one part to another. If I go back to edge flange, edit that feature, I now have all the capabilities I had before. I can make this 2.5 inches. I can change this to 60 degrees. So you can see it continues to update. You can always update. One other thing about the sketch, we're not going to go into this so much, but if you open up this sketch relationship, edit sketch, just like we had done before, you can delete some of these geometric relationships and actually begin to change the shape of this flange. All right, so you can have a high level of editorial capabilities with this flange. Now all of a sudden we've created a notch there, and there's ways to be much more didactic about how you create something like that. But we are not actually going to be editing flanges at that at the sketch level. So if you did do that and you want to get back to it, you can go back to edit sketch, right? Because you can't undo those things. So go to edit sketch, add vertical. This has gotten very large. We can just drag this down. It's not at the right height that we had before, but we can edit. We can get out of that sketch, go to edit flange, edit the feature, and now it's at some random number, right? 2.84 inches. So let's just bring this back down to 2 inches, and there we go. So we've created one flange. Now we want to create a second flange. Right? We want to create a flange on top of this flange. So we come back up to the edge flange feature, come in, select that line, select that edge rather, click into space, And let's say we wanted this to be, right now it's at 90 degrees to this material here. We can't go less than 90, we can't go more than 90, right? Because otherwise we're getting an interior angle that is less than 90, which is not allowable. Our brake can't do that, actually. It has to be at least 90. So 90 degrees. Let's actually call that, let's say this is going to also be at, let's say this is going to be at 30 degrees. So, and it's 30 degrees, and let's say this is going to be also 2 inches. Alright, so we've got 4 inches here, 2 and 2, that's 8. So that's actually going to be a little bit too, that's going to be fine. So for what we want to do next, actually, we need to make this 60 degrees. I want this to be perfectly parallel with the base flange. Right, this was the base flange. Here's our 60 degrees. So this is going to be one flange. You can see it defaulted to material inside and the measuring the interior angle. Likewise, I'll just show you again. This is material outside, the whole bend outside. We want material inside. Okay, check. So the next, we want to make one more flange, because what we want to do now is we want to have the default flange coming down 1 inch on this edge. This is going to be a flange that, if I zoom out here, this is going to be a flange that's perfectly perpendicular to this. This is going to be a consistent edge that every model is going to have. So come back to edge flange, select an edge, come straight down. As you can see, it's 90 degrees. Inside, in measuring the inside dimension, this is materials on the inside. Turn this to 1 inch. That now is 90 degrees, straight down. That's going to allow us to, let's get out of this sketch, that's going to allow us to connect to another part on an adjacent panel. So all these panels will connect to one another after you've made them. Now if you wanted to come in and play with the angles of these flanges, you just have to keep adjusting so that this edge flange is perfectly perpendicular to this base flange. So we've got one side. You could, in theory, go ahead and make the other side the same way you did, with adding more edge flanges, but we don't want to do that. We want to have another side that's a perfect mirror of this side. It's not required. You could come in here, make an edge flange, have this come up, and have another side that was very, very different, right? That came down something like that, and we can make that 1 inch, and then you can make another edge flange coming off of that, coming straight up, turn this 60 degrees. Actually, I'm not sure what this other one was, so let's check on that. This is 21 degrees, let's make that 30 degrees. Let's come back into this edge flange we just created. So that's now vertical. We've got 30, 60, that makes for 90, right? So, and we can turn this to 3 inches, right? So you could make a shape like this. But if you didn't want to have a irregular shape, if you wanted to have a perfectly symmetrical shape, then what you'd want to do is mirror those features, mirror these 3 flanges that we created before. So let's delete. So yes, we want to delete the feature. Let's delete, right click, delete. We want to delete the feature. Now you could just delete the sketch, and it would leave, if you just delete the sketch, we would also delete the feature because it's based upon one another. Okay, so to do a mirror, you can mirror entities on the sketch itself, but since we want to actually mirror a 3-dimensional feature, we're going to go to Features, Mirror, And if you hold over any of these, it'll give a little explanation. So mirror, this mirrors features, faces, bodies about a face or a plane. So if I click on mirror, first thing it's asking me to do is select here a mirror face or plane. So we don't have a plane we're mirroring about. What we want to do is actually, remember we started drawing on the top plane? So if you look at the right plane, that's the plane we want to mirror about. Does that make sense? This is the center of our base flange. We want to mirror this piece back to this side. If we were to click the front plane, that would actually mirror something in the exactly perpendicular in the opposite direction. So we're going to mirror about this right plane. This is the advantage of starting with your origin in the center of the piece as well. Features to mirror. This is where the design tree comes in handy because you can just begin to select these features. That edge flange. I'm going to select this edge flange. And you see how they're building up there. I'm going to select this edge flange. So those are going to be the three features we're going to mirror. We're not mirroring any faces, nothing like that. Check. So now we've got a perfectly symmetrical piece. If I was to go into this edge flange here, edit that feature, make this 4 inches, let's say, everything grows accordingly. All right? So now we've built up a piece starting from this original base flange. How do we know that this piece is actually going to be 12 inches when we flatten it? Come here to flat pattern. If you click on flat pattern, you have an option to unsuppress. Now just a note about that feature, if you click on any of these features, right, you have the ability to hide it. So if I hide that feature, it hides everything because it's been built off of that feature. If I hide this last feature, it'll hide everything as well. So all these have been connected, so you can't just hide one without the other, hiding the other. If I suppress it, this one I can just hide. Oh, I guess not. If I suppress it, it'll actually, the difference between hiding and suppressing is that if there is a feature that you want to have update but just not see, you hide it. If you suppress it, it won't update if you add another feature to that. So flat pattern, unsuppress, folds it out, and now we can actually go into sketch, smart dimension, reference dimension, come in here, select that whole line. So 17.87 inches. So we were working with whole numbers before. 17.87. The 87 is the deformation from the folding itself. 17 is too much, right? We were 5 inches over. So let's unsuppress. We changed this first of all, right? We made that much longer than it needs to be. So we can get rid of, if we make that 2, now that'll get rid of 4 inches right there. We can come back, unsuppress, take another smart dimension on there, 13.87. So we're still over, but not so bad. So let's come back in here, and let's go to this next flange. Let's actually turn this to 1.5. Now we're going to be at 12.87, still a little bit long, and in order to make up for that, we can actually, let's see if we can come into editing this feature, and what I was hoping was that if you look at, I was hoping that by putting on the inside we wouldn't get these extra little extra little bits of material. But that should be fine. So what we're going to do is actually we're going to allow this last edge flange, or rather we're going to go right into the base feature, edit feature, and we're going to go edit sketch, and we're going to turn this, make this 3 inches. Edit that, exit that sketch. And now what we've got here, if we unfold this and we check this dimension, we've got, I don't know if you can see, 11.87. So we're very close to 12. For the purposes of this assignment, that should be completely fine. If we wanted to be exact to 12, we would have to go into how the deformation is happening at these points right here. There's in the next assignment, or rather the next sheet metal part we're gonna create, we're gonna look into exactly how, if you wanted to start with the sheet itself, the full 12 by 24, adding bends to that. So, or rather, drawing bends on that. So you're starting with the full material and bending from there, whereas what we did here, which was add bends. So at this point now, we've got a fully functioning sheet metal part that we can flatten, we can export. If you go to unsuppress and then you right click, you can export the flat pattern. We can make a drawing of this that shows the angles at which all these need to be bent, and it's ready for export, for fabrication. So take a short break, and we're going to next look at how to add holes onto this feature.